Welcome to What Can Secondary Math Teachers Learn from Elementary Teachers? I'm glad you chose to spend some time with me this afternoon, and I hope you too can learn some valuable instructional practices from our elementary colleagues. My name is Julie FRIZZELL, and I'm a secondary math consultant at Region 10. As a classroom teacher in middle and high school math classrooms for over 25 years, I believed that I knew everything I needed to know about teaching math when I began working at Region 10 9 years ago. But I was wrong. While secondary math teachers are definitely content experts in their classrooms, we don't necessarily have the pedagogical background that many elementary teachers have. And I have learned so much from my elementary math colleagues over the years. I'd like to share some of those things with you in this video, and then give you the opportunity to explore some resources on your own afterwards. During this recording, I'm going to briefly share with you about workstations and small group instruction, manipulatives, and thinking routines. So let's get started with workstations and small group instruction. Essentially, there are two parts to this topic: workstations for the whole class and small group instruction with the teacher. We'll discuss both parts separately and together. I'm not a huge fan of AI, but I'm always trying to stay current on what's happening in technology. So I went to ChatGPT for some help in preparing for my workshops this summer. One of the things I wanted clarification on was the difference between stations and centers. It turns out that the terms are often used interchangeably, and in my mind, I use either term when referring to places where students work independent of the teacher. Technically, especially in elementary classrooms, centers are more permanent than stations, but both are used by students to practice and apply problem-solving skills to content in the classroom. I also wanted to know what exactly is considered small group instruction. In a secondary classroom, like an elementary classroom, it involves the teacher working with a small group of students while the rest of the class is engaged in other meaningful work. This allows for more personalized and targeted support, helping all students to deepen their understanding and improve their skills. Small group instruction can include students grouped based on their learning needs. Groups may be heterogeneous or homogeneous, depending on the lesson objectives. The teacher can provide targeted instruction based on the needs of the group. This could involve reteaching concepts, providing additional practice, or challenging students with more advanced material. The teacher can adapt instruction to meet the needs of students in the group. This may include using different strategies, manipulatives, or approaches to cater to different learning styles. Students work on problems or activities under the guidance of the teacher. The teacher may model problem-solving strategies, ask probing questions, and provide feedback to support student learning. Students in the group can work together to solve problems and discuss mathematical concepts. This encourages peer learning and can deepen understanding through discussion and explanation. The teacher can assess student understanding during the small group instruction and provide immediate feedback to address misconceptions and reinforce learning. And small group instruction can be part of a rotation model where students rotate through different stations, including independent work, small group instruction, and collaborative activities. The best advice I've heard about small group instruction is to start small. As with anything else that's new, don't try to do too much too soon. Start by just pulling a small group while the rest of the class works on something else. Get used to the practice of using data to lead small group instruction, whether for enrichment or intervention. Once you and your students are comfortable with you working with small groups of students, introduce stations as a once-a-week activity for the entire class period. On that day, students get to practice what they learned during the week with stations. While they're working, you can continue to pull students either as one of the stations or pull specific students as needed. This is a big one, especially at the secondary level. Students don't have to actually move. If students out of their seats or managing transitions sounds overwhelming, then let the station rotate instead. When I taught high school students, I couldn't deal with all the movement of big bodies in my small classroom. So I put everything for a station in a wash tub, and that rotated from group to group. Maybe you have 30 students, but only 3 activities for stations. 10 kids in a station won't work well. You can always have 6 or 10 stations with repeated activities. You get to keep the group small, but not make extra work for yourself. Over time, you'll build up a wealth of activities, but you don't have to have them all at the very beginning. When you, the teacher, are working with students in a small group, here are some things to keep in mind. Quickly assess what students know. This can be as simple as an exit ticket or as formal as a pre-assessment. Or you can use the data that you already have to determine who needs your support. I'm a firm believer that all students deserve time with the teacher. Now that you know who needs your support and who could benefit from enrichment, you can create a small group of students who generally need the same level of support. Obviously, this isn't going to be perfect, but do the best that you can. Keep it quick. Remember that you want the students to be doing the work, so don't try to reteach a lesson verbatim. Do a quick 1 to 2 minute review and then begin scaffolding or extending the skill. Scaffold the skills. Look for misconceptions and stumbling blocks or places that you can extend the learning. Check and individually correct any misconceptions. Look for patterns. If a student is doing well, let them move ahead. Record and repeat. It's important to keep notes on your students and/or your groups. While you're working with your students in a small group, the rest of the class need to have something productive to do. Here are some best practices for the math station students are doing without you. Visuals and timers are your friend. Set a big, loud timer that all students can see and hear to keep everyone on track. If you're having students move, practice. Set a timer for 1 minute and set high expectations for how you want this done. Simplify your groupings at first. Groups can be homogeneous or heterogeneous learners. The groups can stay the same for an entire unit or for months. If you're familiar with Peter Liljedahl's Building Thinking Classrooms, you can frequently form visibly random groups. Change it up, but also keep the routine. For example, there might always be a text station, but what program they use can change each week. Have a plan for students needing help or checking their answers. If necessary, provide students with something self-checking or an answer key that they can look at. Maybe they put their solutions into a Google form or scan a QR code to check their work. And think about the amount of time it will take to complete the activities and try to make them equal or longer than the length of the station. What you don't want is one station that takes 5 minutes and another station that takes 20 minutes to complete. Another thing that I've learned from my elementary colleagues is that manipulatives are useful for all students. According to Confucius, I hear and I forget, I see and I remember, I do and I understand. When working with manipulatives, students do the math. I went back to ChatGPT for a definition of manipulatives, even though I had a pretty good understanding of what they were. They're physical objects made specifically for math or not, that are used as teaching tools to engage students in hands-on interactive learning of the math concepts we're teaching. Math manipulatives are beneficial for middle school and high school students for several reasons. Middle school students are transitioning from concrete to abstract thinking, and manipulatives provide a concrete representation of abstract mathematical concepts, making them easier to understand. Just like middle school students, high school students can benefit from manipulatives to develop a deeper understanding of abstract mathematical concepts, such as algebraic expressions, trigonometric functions, and geometric theorems. Manipulatives make learning more interactive and hands-on, which can help to keep students engaged and motivated to learn. Manipulatives help students visualize complex mathematical concepts, which can improve their understanding and retention of the material and ability to solve problems. Manipulatives allow students to explore mathematical concepts through multiple representations, such as visual, tactile, and kinesthetic, which can cater to different learning styles. Manipulatives can be used to encourage students to explore mathematical concepts on their own, leading to a deeper understanding and appreciation of the subject. Manipulatives can be used to create real-world problems that require students to apply mathematical concepts in a practical context, helping to develop their problem-solving skills. Manipulatives can be used to model real-world problems, helping students see the practical applications of the math they're learning. And using manipulatives often involves working in groups, which can help students develop their collaboration and communication skills. Many teachers are reluctant to use manipulatives for fear of what students might do with them. As with any other resource, teachers need strategies for managing manipulatives in their classroom. Students are going to play with manipulatives, so when you first introduce them, allow some time for play. Let them get it out of their system. Then explain how the manipulative will be used as math tools and not just for play. Share with students your expectations regarding the use of manipulatives, practice routines and procedures, and hold students accountable for their responsible behavior. And finally, I'm going to share some thinking routines resources with you. Back to ChatGPT for a definition. Thinking routines are structured and easy to learn strategies that support thinking. Just like a routine that you might have for getting ready for work in the morning, a thinking routine frees up mental space to allow for more important things to happen in the classroom. On the screen are some examples of thinking routines that you may or may not be familiar with. Robert Berry, when he was president of National Council of Teachers of Mathematics, wrote about the importance of utilizing instructional routines. I'll give you a moment to read the quote on the screen. A relatively new resource for me for thinking routines is Harvard Graduate School of Education's Thinking Routines Toolbox. I learned of this from my ELAR colleagues at Region 10, and this includes a number of very short but powerful routines. A couple that you might have heard of before are See, Think, Wonder, and I used to think, now I think. Another great resource for thinking routines is Lead Forward's Instructional Strategies playlist. On this list are a few of my favorites, and they remind me of some math-specific variations. Four Corners, which reminds me of Which One Doesn't Belong. Would You Rather, and Debate Math is an interesting variation on this idea. And Pick Up the Slip Up is a variation on the Two Truths and a Lie game. When it comes to reasoning routines, these two books are great resources. These 6 routines shown on the screen are great for helping students think about the relationships and mathematical structures in the problems they're solving. And last but not least, I want to share a couple of my favorite websites for thinking routines. Fawn Wynn's Visual Patterns and Andrew Studell's Estimation 180 are great ways to help students develop number sense and mathematical reasoning. All of these resources are shared with you in the document linked on the next slide. This brings us to the end of the video portion of this session. On the screen is my contact information if you have any questions. At this time, I encourage you to open the document linked on the screen through the QR code or bit.ly. From there, feel free to explore any of the resources shared with you. Thanks again for joining me, and I hope you learned something that you can use with your students in the future.